So in this example, we will see the multi-class classification for MNIST fashion dataset. In the previous example, we used Keras and we have got an idea how it can be used for the binary classification with some random dataset. In this example, the MNIST fashion dataset will be used for the classification purpose. And the first cell is the import cell as usual. So we have all the required imports there. And then we are loading the dataset, the fashion MNIST dataset with the help of TFDS. This is TensorFlow datasets, and we are loading it using the load data method. So once I run this statement, it will load the dataset and it will split the data into xtrain, ytrain and xtest, ytest. I'm just printing the shape of the ytrain and ytest. You can check the shape of xtrain and xtest by changing the values. You can see that these are the again 28 by 28 grayscale images, and they represent apparels like shoes and clothes. Let us draw some of the samples here. So let's have a random index. So first is the ytrain image index. So I'm printing the image label for the image number 350, and then I'm trying to show the image actual image of the same number, and since these are the grayscale images, we are using grays. So it shows me the label 2 and it's a kind of a t-shirt as I can see from the image. Now if I change this to some other number, say for example, let's see the 0th image, it looks like a shoes, and similarly you can check for different images. This is another shoes. And after having the look on the data, it's time to set the model. Again, we will be using sequential method. Now the first layer which we are using here is flatten, and we are passing the input 28 by 28. So this is the first layer where we are setting the input shape. So this is the input layer, and after that there are three other layers. These three are the hidden layers where I'm setting the activation to ReLU, and the number of units in each layer is set to 2048, 1024 and 1024 respectively. The final layer is the output layer, and since we have 10 different classes, we are setting the value to 10. If you remember in the previous example, when we used the binary classification, the possible value was either 0 or 1, and hence we set it to 1, and the activation was kept to sigmoid there. Here we are using activation as a softmax, and the model can be seen with the help of model.summary. So you can see the summary here, and you can see different layers. First is 784, and the 784 is nothing but it is a multiplication of the input shape 28 by 28, and then you have the layer 2048, 1024, 1024, and the final layer is 10. After seeing the model and its summary, now it is time to compile the model. For the compilation, we are setting different parameters. Here I am setting the optimizer to Adam, and we have seen different optimizer in the previous example. And the loss here is set to sparse categorical cross entropy. You can take binary cross entropy for the binary classification, and for the categorical, for the multi-class classification, you can take the categorical cross entropy. Again, we are trying to find the accuracy, so I am setting the matrix parameter to accuracy. Once I compile, I can fit my model, and I can fit it by providing xtrain, ytrain. I'm keeping only 2 epochs at the time being to see the results, and I'm setting the verbose to 2. While I'm fitting the model, I'm setting the return value to history because I want to preserve the history, and then I will use this history's epoch and accuracy for the final output. So let's see what results we are getting. So it will run through over 60,000 different samples, and it will be executed for 2 epochs. So we may have to wait while it gets executed, and it will take some seconds. We'll see how this can be improvised while it gets executed on the GPUs. Currently we are not executing it on GPU. Okay, so as you see, after 2 epochs, the accuracy which I am getting is around 83%, and time taken by each epoch is around 51 seconds or more than that. So first epoch took 51 seconds and second epoch took 54 seconds. This is being executed on the CPU. Now let us see if the same code gets executed on the GPU. So we will move to the collab, and the same code we will run through the cells one by one. We'll try to see how quickly it can execute on GPU. Again, this is drawing the image. We are fitting the model, and then we are compiling the model. And before I fit the model, I should check whether my runtime is set to GPU or not. If it is not set to GPU, I can change it to GPU, and then I can say save, and now it's time to run this. So as you can see, it took only 6 seconds for executing the model, and the accuracy is 8326 here and 8341 is almost similar, but the difference is in the speed. So while you are working with the complex neural networks, or while you have to work on the large data sets, it's better that you set your runtime to GPU. The Jupyter also allows you to set the GPU, but we will see that in the future lectures. So this is an example how multi-class classification can be achieved using the Keras.